All right, so here's a different type of collision than what we looked at so far. So let's take a look at what happens. So here comes a van and a car. And let me give you a chance to watch that again. And think about, how is this collision different than collisions we've looked at so far? This collision is different because they're in two different dimensions. You could think of the car moving in the X dimension and the van moving in the Y dimension. And did you notice that the van's hatchback popped up during the collision? So like I said, we had the car, maybe think about that, moving in the X, and the van moving in the Y. How have we dealt with things where we had X and Y in the same problem in the past? Remember, we've done X and Y separately. Remember, we've done XY charts. And we even had to do like V cosine theta and V sine theta to split a vector up into its X and Y. We're going to do the same thing here. We're going to say that momentum in the X is equal to the momentum in the X after, and momentum in the Y is equal to momentum in the Y after. We can go down through, we can find velocity in the X after and velocity in the Y after. And then we would have to do Pythagorean theorem with the velocity in the X after and velocity in the Y after to find the actual velocity. And then we could do inverse tangent. Remember, theta is the inverse tangent, would be a velocity Y after over velocity X after, because that would be the opposite over the adjacent. For this problem, momentum in the X would just be from the car. So we would say that we had like mass car, velocity car equals, but then they would move off together afterwards. So we would have mass van, velocity van after plus mass car, velocity car after. Which we again could just say that velocity van after is equal to the velocity of the car after, which is the velocity after the collision. If you included mass van, velocity van before the collision, that would be okay, but when we're looking in the X direction, the velocity of the van would be 0. We would then repeat the same thing, but now only looking at the Y, where in the Y, the velocity of the car is 0, but we do have velocity from the van. So the main idea, if we have multiple directions, maybe we have a car this way, and maybe a van coming in this way. We have motion in the X, we have motion in the Y. It's no different than what we did before, but just look at the X stuff, X and Y separately. So momentum in the X, momentum in the X prime, momentum in the Y equals momentum in the Y prime. In this case, the car would be all on the X. We would have to be given some kind of angle here, and you would find the van X and then also the van Y. The van X part would be used over in this, and the van Y part would be the only thing before the collision because there is no momentum from the car before the collision.